We're now going to move on from list views and look at timers, which will allow us to consider some rather more complicated Android concepts such as threading, handlers, and runnables. So don't worry too much about those. We'll explain them when we get there. But for now, let's create a new project called Timer Demo. So we actually saw timers a few videos ago in the previous section, but we didn't look at them in much detail. So they're very useful. They allow us to delay the running of a particular activity, whatever that might be, and do it, say, 2 or 3 seconds in the future, which we're going to use a lot in the next couple of apps. There are lots of different ways to make timers in Android. I'm going to show you 2 of them here. So one will be used primarily to run a certain bunch of code every second, and then the other will be used as a countdown to a particular event. So let's jump straight over to mainActivity.java because we're not going to be adding anything to the user interface in this video. So here we go. So in onCreate, we're going to start by creating a handler. And I'm going to call it handler. And it's going to be a new handler. And make sure you use Android OS handler there to get the right framework. So a handler does a couple of things, but one that's relevant to us here is it allows chunks of code to be run in a delayed way. So possibly every second, every 5 seconds, every 10 minutes, however you want to do it. And the handler controls the timing of these events or chunks of code. Now, these events or chunks of code have names themselves, and they are called runnables. So we normally call them just run. And so our runnable is going to be a new runnable, like that. And you can see that we've got the default code set up for us there. So in here, insert code to be run every second. So it's overriding the default run method. You can think really of runnables as being methods that can be run every second or every 5 seconds or whatever. So once you've entered your code that you want to be run every second, you then have to give it instructions to run that every second. And it's the handler that takes care of that. And what we can do is handler.post delayed. And then we want to post this. So in this context, this refers to the runnable here, the run method, and then the number of milliseconds that we want delayed. If we want it to run every second, then we want it to be delayed every 1,000 milliseconds. So we've got quite a complicated chunk of code there, but just to run through again what's going on, we've created a handler which can control the timing of certain methods. We've then created one of those methods, which has a special name called a runnable. And then we've added the code to be run every second. And then we've used the handler to run this again 1 second later. So then each time this is being run, it's being instructed to run again a second later. So this will essentially run every second. So let's just do a simple log post. Runnable has run. A second must have passed. Simple as that. And then we have to actually initialize the runnable in the first place, which we do in a very similar way to how we made it run 1 second later. We just use handler.post and then run. And that will then execute the runnable right from the start. And then as soon as that's run the first time, then it will call its run the second time and keep on going forever. So let's take a look. We should find now that this is posted to the logs every second. We'll run it in the emulator, even though we don't actually need to open the emulator this time. Everything that we're interested in will appear in the logs. There we go. So it's running every second. Fantastic. So that's more or less all we're going to say about runnables for now. But I am going to show you another way of doing timers in Android. I'm just commenting that out so it won't run the second time. The other useful way to do a task regularly is to use a countdown timer. So let's see how they work. We'll create a new countdown timer. And then we need to give that two numbers, which is the number of milliseconds until the countdown has run out, and the frequency with which we want the counter to tick down. So if we wanted to count down for 10 seconds, then we would use 10,000 for 10,000 milliseconds for our whole countdown, and then 1,000 for the time for each tick, as it were. So this is then going to count down from 10 seconds to 0. And then we add our code for our countdown timer, which is going to create two methods. So the first is on tick. So this will happen every time we get a tick. So in our case, every 1,000 milliseconds, or every second. And that will receive a variable which is a long, which is essentially a big integer. And we'll call that milliseconds until done, because that's what it is. So this method here will give us this variable, milliseconds until done, that we can use if we want to. And the other method that we can use is public void on finish. And not surprisingly, that will happen when the countdown is finished. Whereas this one happens countdown is counting down. So in our case, it will be every second, and this will be after 10 seconds. There we go. I'll just put in a semicolon at the end there. So just to see what this is doing, let's just quickly log. This is going to give us seconds left. And then we can get that from milliseconds until done over 1,000, because that will give us the number of seconds left rather than the number of milliseconds. And then we will need to convert that to a string. And we can do that using string and then dot value of. And that will then convert our long to a string and allow us to log it. And then, just so that we can see how it looks, we'll log done. Countdown timer finished. And then finally we just need to start that, which we do using dot start. There we go. So hopefully that makes sense what we've done there. We've created a countdown timer that will last for 10 seconds and tick down every second. And then each tick, it will log that. And then at the end, there we go. 3, 2, 1. And finally, countdown timer finished. There we go. And the advantage of this is the countdown timer object is then destroyed when it's finished. So if you only need it temporarily, then a countdown timer is probably preferable to using a handler like that, which will continue to exist even when it's finished. Okay, so that's all we're going to do for now with countdown timers and handlers and runnables. In the next video, we'll be using Countdown Timer specifically to make our Egg Timer app. See you there.